Hello student. Now we'll see the new point, that is derivative of implicit function. See, basically there are two types of function. First is explicit type of function and second is implicit type of function. Now what is the difference between this explicit function and implicit function? See, so far we have seen one type of functions only, that is y equal to x square plus 3x plus 2. This is just for example. Now check this second one, x square y plus y is equal to x cube minus 3xy square. What difference you can see in these two examples? See, this is explicit type of function and this is implicit type of functions. But how will you make difference between explicit and implicit? If you see the first, which is explicit actually, but how you will recognize it is explicit function? See, y, this is the function, y is expressed in terms of x only, or you can say the function which is expressed in terms of only one variable. So y function expressed in terms of one variable, that is x only. That type of functions are known as explicit function. But if you see this function, x square y plus y is equal to x cube minus 3xy square. Here both sides of the functions are expressed in terms of x and y. So what is the definition of implicit function? The function which is expressed in terms of x and y both are called implicit type of functions. Okay. Now in this point we have to find out the different. We will find out the derivative of implicit type of functions only. Okay. Let's see the first example. See, in all this example our target is same, that is to find dy by dx. Okay. So how to find dy by dx or how to differentiate this implicit function we'll see here. Okay. Now see the first example, x cube plus y cube plus 4 times x cube y is equal to 0. This is implicit type of function. We can see the whole function is expressed in terms of x and y in both form, right? Now we have to differentiate this function. So x cube, derivative of x cube is 3x square, derivative of y cube will be 3y square. But don't forget we have to differentiate all the term with respect to x. So we have to take separate derivative of y also, which is dy by dx, right? Now last term, that is 4x cube y. Here 4 is constant, so we'll keep that 4 as it is because we will not differentiate 4. Okay. Now we have to differentiate x cube and y, but x cube and y are in product form, so obviously we'll use product rule of derivative here. Now x cube, that is first function constant, derivative of y which is dy by dx. First function constant, derivative of second function, plus second function constant, derivative of x cube will be 3x square, and derivative of 0 on the right side, which is always 0. Okay. Now we are done. Now this 4 will multiply into bracket. So what will get? 4 into x cube dy by dx, 4x cube dy by dx. Now 4 multiplied to this second term also, 4 into 3 12, and this x square y as it is here, right side 0 as it is, right? But as I told you, our target is same, to find dy by dx. So what we'll do, we'll combine all the dy by dx term on left side and non dy by dx term will shift on the right side. Okay. So on the left side we have two dy by dx term, 3y square and 4x cube. We'll combine them and we'll factor out dy by dx from it. See, 3y square and 4x cube are here and factor out dy by dx. Now non dy by dx term will combine this 3x square and this 12x square y is here. Okay. Now both term will shift to the right side, so it becomes negative. So both term become negative. Now this total bracket, if you shift on the right side, it will get divided to this right side. So on the left side you will left only dy by dx. That is your differentiation or derivative of this function. Okay. Now similarly, let's see the second example. That is cos xy is equal to x plus y. Okay. Now we have to differentiate here, but don't forget x and y are in product form. So obviously we'll use product rule for that xy, but before that we have to differentiate cos. So derivative of cos is minus sine of xy. We have done with cos. Now we have to differentiate xy using product rule of derivative, right? So product rule of derivative will apply for xy. Now right side is x and y, derivative of x is 1, derivative of y is dy by dx. Okay. Now we are left with differentiation of xy here. So that we'll do here. So first is x is constant, derivative of y is dy by dx. Now y is constant and derivative of x is just 1. Now y into 1 is just y. Now this minus sine xy will multiply to both term in this bracket. So minus sine xy into this x. Minus sine xy x dy by dx as it is. Now minus sine xy will multiply to this y also. So minus y into sine xy. Right? Come to the right side is 1 plus dy by dx as it is here. Right? Now you can see there are two dy by dx term. One is on left side and other is on right side. So what we'll do, this right side's dy by dx term will shift to the left side, so it become negative, right? And this left side is non dy by dx term will shift to the right side. Now this dy by dx term is positive. When you shift that to the left side, it becomes negative, right? So we'll factor out dy by dx from this term and this when we shift to the left in both the terms, right? So we factor out dy by dx term, we get this bracket. Okay. Now this minus y sine xy will shift to the right side, so it becomes positive. See, this one as it is here and this minus y sine xy become positive here, right? Now isolate dy by dx term on left side and shift this whole bracket to the right side. It will divide to this 1 plus y sine xy. That is your final answer, that is dy by dx. Okay. Okay student, now let's see the next example. If y equal to 1 plus x into e raised to y is equal to 1 plus x into e raised to y, then show that dy by dx equal to e raised to y upon 2 minus y. Then we have to show that derivative is e raised to y upon 2 minus y. Now y equal to 1 plus x e raised to y, this is our given function that we have to differentiate. Okay, so now differentiate this function with respect to x, both sides. Derivative of y is dy by dx. Derivative of 1 is 0 because it is a constant term. But when you differentiate x into e raised to y, we can see x and e raised to y, these two are different function, but they are in product form. So we'll use product rule of derivative, right? First function constant, derivative of second, plus second function constant, derivative of first. So first function x, which is constant. Now take derivative of e raised to y. Derivative of e raised to y is e raised to y into dy by dx, plus e raised to y constant, and take derivative of x, which is only 1. So e raised to y into 1 is just e raised to y. Okay, if you want, I will write that 1 here. Okay. Now we can see there are two dy by dx term. One is on left side, another is on right side. So we'll combine dy by dx term on left side and we'll shift non dy by dx term on right side. So when you shift this positive term to the left side, it becomes negative. We can see that, right? So this dy by dx and dy by dx, if you factor out, so here we get 1 and here x e raised to y as it is. Now what we left on the right side? Right side is just e raised to y. We'll call this equation number 1. Now go to your original function again, that was y equal to 1 plus x e raised to y. This is your function, right? If I shift that 1 to the left side, it becomes y minus 1 and this x e raised to y will be as it is. See, in this equation number 1, this x e raised to y, can I replace this x e raised to y by this y minus 1? See, this term I replace by this y minus 1, check here, right? And this dy by dx as it is, right side e raised to y as it is. Means we are applying this in equation number 1, right? Now this minus sign when multiplied to bracket, this y become negative and this 1 become positive. So 1 plus 1 becomes 2. and minus y as it is here, dy by dx as it is, e raised to y as it is. Now if you shift this bracket on the right side, it will divide e raised to y, correct? So dy by dx equal to e raised to y upon 2 minus y. That is what we were looking for. Getting? Now see one more example. This is slightly different example. Y equal to under root log x plus under root log x plus under root log s. This is infinite time. Okay. Then we have to show dy by dx equal to 1 upon x into 2y minus 1. Okay. We'll write our given function as it is here. So what we'll do, we'll take square on both sides to get rid of this outer side's root sign. We'll take square on both sides. So if you take square on left side, it becomes y square. But when you take square on the right side, this square on the right side, if you take square here, this square and this outer side's root sign will get cancelled out. Correct? So if you cancel out outer side, this inner root sign will be as it is. We'll remove sign of this first log x only, like this. And another root sign will be as it is. Right? Now, if you see from here to here, root log x plus root log x plus root log x, this is infinite time. But root log x plus root log x, this is infinite time. Value of this total function was only y. So can I replace this total bracket by y only? Right? So you get y square equal to log x plus y. Right? Now this function looks in easier form to differentiate. Now differentiate both sides with respect to x. Derivative of y square will be 2y. And derivative of y will be just dy by dx. Now derivative of log x is 1 by x. Derivative of y is dy by dx. Again you can see there are two terms of dy by dx. One is on left side, another is on right side. So right side's dy by dx will shift to the left side. Okay. See 2y as it is. When you shift dy by dx to the left side, it becomes negative. So we can factor out 1 from it and factor out dy by dx. And this 1 by x as it is on the right side. Now this bracket shift to the right side, it will divide, right? 2y minus 1 and 1 by x was already there. So final answer dy by dx equal to 1 by x into 2y minus 1. That is what we want. 1 upon x into 2y minus 1.